Indonesia, a tropical country located in Southeast Asia, is a home to the fourth most populous country, with 18 million citizens with a lack of access to safe water and 20 million with a lack of access to proper sanitation. With pollutions causing polluted waterways and the increase in deforestation, soil degradation, and extreme weather conditions causing water availability, regions like South Sumatra, West Nusa Tenggara, and South Sulawesi will experience a crisis of clean water by 2045. While in Java and Bali, the availability of clean water has a much more critical status. Overall, in most regions in that year, the proportion of water crisis areas will increase from 6 to 9.6%. That being said, we have been led to develop a product that ensures the sustainability of water resources and ecosystems of Indonesia. Represent you, Soares.
No, not that type of risk, but result filtration, which is a major part in our product, which will be used for filtration. Our product is a wastewater recycling system, which turns wastewater into clean water.
Our innovation consists of a three-step process. First, separate large particles such as feces from wastewater, black water from individual households, travels into specific septic and anaerobic tanks to separate and settle particles. Furthermore, oil and grease remain floating at the top as they travel into another septic tank for extra thinning to ensure the sludge from wastewaters will be broken down. The next three tanks that are located up nearer to the surface use the natural filtration process and the phytoremediation method, also known as razor filtration.
That is a form of phytoremediation that involves filtering contaminated groundwater, surface water, and wastewater through a mass of roots to remove toxic substances or excess nutrients. The root systems of wet plants work wonder through the group of microorganisms it contains by actually biodegrading most minor pollutants and breaking them down into harmless elements. In fact, some heavy metals contained in wastewaters can actually be absorbed into the tissues of wetland plants. In addition, wastewater that flows through this constructed wet life ecosystem gives life to aquatic plantations that can increase the oxygen and moisture into the air. When assuming each household in Indonesia could implement this system, it greatly improves Indonesia's urban areas to reduce local greenhouse gases.
The second step uses large masses of plant roots, also known as rhizospheres, of wetland plants such as sunflowers and tobacco, and gravel as a filament to filter wastewater from individual households. It uses biomediator where contaminants and toxins from wastewater are removed and oil spills that may have been built up in tanks 1 and 2 are cleaned. These tanks separate soil from the inward structure where water travels through the feed of plants and for watering recycling.
In the final rank, aka the sixth tank, the water undergoes advanced treatment to reverse osmosis, a reversing of the natural osmosis flow from saltwater to freshwater. Within this phase, a semi-permeable membrane is utilized to effectively eliminate impurities such as salts, bacteria, viruses, and various contaminants of up to 99.99%. In this process, water is forced through a membrane under external pressure of a pipe, allowing only the water molecules to pass while blocking the larger and concentrated particles, ions, and pollutants from entering.
One benefit is the lack of dependence our innovation has on renewable sources and energy that deem unpredictable during a time of high humidity and low precipitation. For example, the water extraction from air that may have a limitation in moisture content. Instead, it focuses on reusing and recycling wastewater that would have otherwise been thrown into sewages.
Furthermore, the system also provides the opportunity for biofuels to be processed from the waste products derived from the first two tanks. This process is extremely beneficial as the most beneficial innovation is created with less substantial equipment and lower budgets as seen in our financial plan. The main concern of this innovation is the possibility for large volumes of water inflow. To combat this, we ensure that there is a downward slope of pipelines between reserve filtration tanks, allowing a continuous flow of water.
Obviously, water will be wasted when processing daily activities, and the amount of water will not remain constant. Therefore, we plan to overcome this weakness into an opportunity by using groundwater. It will then be returned back to maintain a balanced underground condition, where soil quality may continue to thrive. Coagulation and fluctuation is a conventional method used to separate suspended and dissolved components from water. This process allows solid waste and water to drown down into the surface of the tank, decriminalizing against the liquid. By this, black water will still have its visible solid filtered, not only leaving other bacterial compounds in the water.
The Soares, a device which helps to sustain residential area in Indonesia, can help to improve the sanitary conditions and provision of daily water use and enhance living conditions of citizens living in these areas.